about enamel. Enamel is the hardest tissue in the whole human body, and the same applies for animals also. So it is harder than bone. Get back to your places, please. It is harder than bone. And the important thing which you have to remember about enamel is which is the cell which forms enamel. I told you. Ameloblast. Ameloblast is a cell which is forming enamel. The next question is, what is there inside the enamel? So enamel is made of rods. So that is the functional unit of enamel. Functional unit means the main component over which there is stepwise building up and then it becomes a bigger structure. So enamel rod is the functional unit of enamel, and these rods are keyhole in shape. Keyhole is like this. There's a head and then there is a tail. So that is a very important shape wise. Can you see this image? So look at this image. There is a keyhole shape, and this is sequentially ordered and then kept as a tightly packed structure. So the other important thing about enamel is the composition. Composition of enamel is whenever you are doing a hard tissue, there are two ways which we read the composition: organic and inorganic components. So organic components are the proteins and all the enzymatic structures, all of them would come under organic. Inorganic are all the ions. Ions in hard tissue, what are the ions in hard tissue? Basically calcium and phosphorus. There will be trace elements, many trace elements like manganese, zinc and so on. But those are in smaller quantities. So the next thing is, how much of organic and how much of inorganic is the next question in enamel. Very, very important. So it is 96% of inorganic and 4% of organic. That makes it super hard structure. Is that clear? Whereas bone is just half, close to half of inorganic and half of organic. So that is the big difference between enamel and bone, and that is what makes it super hard. So the inorganic component is the predominant structure, and how much it is? 96%. So that gives it, makes it as the most hardest structure. And the other important thing is, I told you already that there are rod-like structures. These rods are not just spherical. The moment you hear the word rod, you would think that it would be a tube-like thing. But it is just not like a tube. The tube itself is taking the shape of a keyhole through and through. So that is one important thing. And where it starts and how it goes. So okay, so enamel rods, how do they go? And this is the dentine, fine. This red is the enamel rod. Okay, so in enamel. So now look at the direction. So the junction between the enamel and the dentine is the dentine enamel junction. So from the junction, these rods would just take a course like this. Okay, course like this towards the surface area. So the number of enamel rods in a small teeth will be lesser in number, a larger teeth will be more in number. The smallest teeth in human dentition, can you tell me which is the smallest teeth in human dentition? The lower ventral incisors. Largest is the maxillary first molar. Okay, so accordingly the number of rods will vary. The smallest tooth will have 5 million rods, whereas the largest tooth will have 12 million. It's just more than double. And another important thing is the length of a rod. If you take one rod and then measure it, it will be more than the length of the enamel, which means that it has got a tortuous course. So it is not straight, it's slightly tortuous. Is that clear? Not very, but slightly tortuous. So that is about the length. The other important thing is the